else is getting in here. Congrats on making it in. Congrats on making it in. I mean, we don't have room for anybody else. There is someone who sits here. So. And then they were like, well, do you want a different room? I don't want a different room. I like this room. This is a good room. And we'd have to actually switch with someone else. There's no other rooms available in Loyola. We're not moving to a new freaking building. No way. Did I actually hit record there?
Yeah.
Yeah. Cool. Thank you. Awesome. All right. So first off, any questions on like anybody start the web work? Have anything they want to talk about?
I don't understand what number 3 is asking.
Let's go.
I had no idea like what it wants.
Okay. That's a good question to ask. Yeah, let's check it out.
Are they the same questions for everyone? Or are they
They're
randomized?
perturbations of each, so it's like the same flavor, but then the numbers and stuff change. So yeah, while I'm doing this, it's going to take a few moments. This is currently due the end of the day on Monday, and I think it's all just Calc 1 stuff. I think it's just basic integration in this first assignment, so it's like called Homework 0 Warm-Up. So it's just the basics. We're going to actually push past that this week into substitution, which I'm pretty sure that Dr. Gravel did not get to. He had mentioned that to me. So some people, has anyone in here had Calc 1 and gone to, I know some have substitution. Cool. We're going to pick it up there in just a little bit, maybe even toward the end of today, but we're going to warm up today first. Hopefully you've tried to log into WebWork. I'm going to extend this through the end of the day. You still have the end of the day. This counts. This is like homework. Just freaking go in and type something wrong. Preferably something right, but you can get credit for typing something wrong. This is 10 points. This is 16 points. This is I want things settled. Like Isaac told me, he couldn't log in, and that's good information. I'm going to fix him up. But we got to have that communication. So let's take a look here at homework set. Let's do progress. Okay. So that was number 3.
Mm-hmm.
Yeah. Oh, what a great one. So, little fun fact about me. Sometimes I will put problems in here that I want you to ask about, and this is one of them. So I'll put things in there, so sometimes you'll be like, what is this? This is weird. And this is such a problem. So here we have f prime of x. This is number 3, so I'll do 3-ish. Right now, that's garbage. Okay. 3-ish. We have f prime of x is 7 over x. I'm just going to modify things slightly. We are told that x is less than 0. And that, I'm doing a bad job remembering, f of some negative number is some other negative number. And f of -2 is -4. Oh, there we go. So what are they asking here? Actually, let's use -1. I think I should stick with -1 to be clear. Yeah, definitely. So they're asking us to find f of x. That's what we need to find here. So we need to move from a derivative to the original function. And so this is integration, right? Moving this way is differentiation. This is taking a derivative to move that way. We're going to have to integrate. So f of x is the integral of f prime of x. And that's actually one of the fundamental theorems of calculus. Remember I said there was 2 parts. This is like the other part. That integration, or maybe this is actually the part we talked about, that the integral undoes the derivative. I didn't write it that way, but that's what that part said. This is really all you need to know about that. So I need to take the antiderivative of that. And we have this thing in our table. So you be sure to check out that table that I posted for you. It is pretty sweet. And I'm going to write this in a slightly different way right here. This is the indefinite integral. So we mostly spend time talking about the definite integral when there's numbers here, and then that can be interpreted as the slicing into rectangles. Indefinite integral is just the formula part of all this. So if I have 1 over x, I would say that the antiderivative of that is natural log absolute value of x, and then plus a c, a constant of integration. So, let me see, so Sophie, it's Sophie, right?
Yeah.
So Sophie, that's why this information is given to me, because I've got this absolute value here and I need to like do some work with that. That's why we need to know the sign of x when we do this. So first off, let's just use this formula. So I want to find the integral of f prime of x dx. And I'm going to use notation, because like I said, notation helps me think, makes life easier. And then I'm going to pull that 7 out in front. And I'm just going to integrate this part right here using the formula. So this is 7 natural log absolute value of x, and then plus c. Let me point out a little subtlety here, because you might wonder about this. This is 7 times this thing, and this thing is actually this. So without the 7 here, I would just write this. So in some ways, it's 7 times this whole thing. The good news is these c's eat everything. So if you take that c and you take its square root, it's still c. You take that c, you multiply it by 7, it's still c. So I'm just going to say this, and I'm going to make a little note here that the c absorbs constants. Cool. So this is actually f of x. This is my raw form. So this is step 1, just getting to there. Does that make sense?
Mm-hmm.
Okay, cool. So I've got a feeling I don't know, let's try something. We're gonna try this out. You could leave that absolute value there. I got this feeling they don't want you to. I think they don't want you to leave that absolute value given the way the problem is stated. So here's a little fun fact, that if I have the absolute value of something, so this means absolute value of something, and I'm putting something here because this could be any expression. This is equal to 2 different things depending on that something. It's equal to just that something if that something is positive or 0. So something is greater than or equal to 0. And I'll give a solid example of this. And it's equal to negative the something if the something is negative. Sorry, that's super shitty writing. Almost illegible. So what do I mean by that? So you're going to be scientists, or business people, or maybe even a mathematician in the group. That would be really cool. This is a way to get rid of absolute value if you understand what's inside here. So you can get rid of this horrid absolute value thing by just using this rule. So what I mean is this. If I say, what's the absolute value of -7? Well, that is a negative thing. So it's actually -7, which is +7. You probably would have just said, oh, it's 7 right off the bat. What's the absolute value of -7? It's +7. You'd be right. This is a slightly more sophisticated way to think of it. What's the absolute value of x if x is less than 0? Then the absolute value of x would be -x. So think about it. This x is a variable quantity. If it's negative, like -7, its absolute value, I have to put a negative sign in front to make it positive. So this is positive, even though it looks negative, because x is negative. So it's a very subtle, very kind of sophisticated thing that they're asking us here. So I'm going to take this, and I'm going to use that fact. And Sophie, I think that's what they want us to do here. So because x is negative, so since x is less than 0, f of x is 7 natural log, and I'll use parentheses, negative x, plus that constant. So that's the super subtle thing they're looking for here. And I have a feeling everybody's problem, x is negative. Anybody else done this one? Checked out number 3? Yeah, did.
Well, I'm doing it right now, I'm putting in, and it says that like c, the variable c is not defined in this context. So
Oh, well, we're not done yet.
Okay.
That's good, yeah. So hold on. We still gotta find c, and that's where this little bit comes in. So far, I've just used this, Jaden, and now I'm gonna use this fact right here. So this is used, let's put this up here, to find the constant of integration. So now we're gonna plug that in. And you're right, yeah, so that's good. That means WebWorks working right. So now, use the fact that when x is -1, f of -1 is equal to, this is kind of a little bit redundant here, equal to -4. So I'm going to plug that into this thing. So in other words, f of -1, I'm plugging -1 in for x. I get 7 natural log of -1. See, I already had that negative in there. And then that's plus c. And that must equal -4. So let's simplify a little bit. So this is natural log of +1 plus c equals -4. What is the natural log of 1?
0.
Ooh, oh boy, oh, that's freaking good, yeah. Let's put a graph up of log. I want you to know this graph. So natural log, so y equals natural log of x looks like this. You should know this, just because knowing these graphs makes life easier when you want certain values. Natural log is 0 when x is 1, or when the input is 1. So this is 0. So this is 7 times 0 plus c equals -4. So now I see that c, because this is 0, c is -4. And then I come back, so then my final answer, and if you put this in there, you're going to get a good answer, or hopefully. So f of x should be 7 natural log of -x minus 4. That would be my answer. So you got to find that c, and then it'll be happy. Hopefully that'll work, Sophie.
Probably.
Yeah. And so I put this problem in there because I wanted to talk about the absolute value, and I wanted to talk about log, and all sorts of things. So it helps me remember shit I want to talk about. Other questions?
We did number 8.
Number 8, sure. So what were you thinking about that one in particular? Did you know where to start, or not quite sure where to start?
I just thought maybe one of the functions that we got was supposed to be a first derivative.
I see. Cool. We're going to make a first derivative, so we're going to get one in there. So this is a great question. Another great question. So this is number 8, so we'll do 8-ish. So number 8-ish would be find f of x. So find the function f if, and then they give us the second derivative formula. And that is here, let's see, I'll make up some stuff. 3e to the t minus 2. And I think they're using sine there, so I'll go cosine. Well, the t, whoa, now I've got t's and x's. That's not good, put a t here. And then they give us two conditions. If f prime of 0, was 0 one of the things they gave, f at 0?
Just f of 0.
F of 0, thank you. Just f of 0 is, we'll make up some number. Shit, I'm gonna put this back to sine, sorry. Because it's not gonna work out otherwise, it'll just be really weird. F of 0 is 2, and f prime at pi is negative 5. No, sure, it'll all work out no matter how, somehow. Yes?
But it didn't give us that one.
Exactly, you're right. So let's talk about that. So yes,
I think what he's trying to say is that both of them are just, for both the answers in the bottom, they're just both normal.
oh, is that
Yeah,
what
it's
you're saying?
just-
Oh, oh, okay, that's okay, cool. That'll still be okay. It just makes life a little more painful. So let's talk about that. Thank you. Thanks for the clarification. I now understand your question. Got it. Beautiful. So you were like, you kind of knew what to do if we got an f prime value, right? So we just have to hold off. We just have to kind of like have a little patience and then a lot of patience at the end. So first off, so step 1 is let's get an expression for f of t. So here I've got f double prime. What do I need to do to get f prime? Integrate, right? So I'm going to integrate. How do I move from f prime to f? Integrate. So I've got to integrate twice here. Because to get from here to there, they differentiated twice. So we're going to undo both those differentiations. And we're going to add constants every time we do that. So, to get to f prime of t, integrate with respect to t. WRT is with respect to. And so I've got f prime of t. Now I'm going to be a little less notation heavy here because this is going to be 3 times the antiderivative of e to the t. It's the antiderivative of e to the t. E to the t, right? Sweetest derivatives and integrals in the world. So here we're using this fact that e integral of e, well, I should just e to the t. It's just e to the t. And then there's like a plus c. But I'm going to tack that on at the end. So I use that first. And now I've got to take the antiderivative of sine of t. What would that be?
Negative cosine.
Beautiful, negative cosine of t. So notice how we had a negative 2 in front already. The sine part goes to negative cosine of t. So really keep track. Use parentheses lots to keep yourself sane and correct. And then we're going to tack on a c. We can just use c. We'll use a d for the next level. So let's simplify. So f prime of t is 3e to the t plus 2 cos t plus c. So let me stop and you tell me. Any questions? We're doing okay? Clean up the rest of this stuff. Good? Yes.
So, do each of those, the integration of e to the t and of sine times t, would they both have a plus c?
True, yeah,
But
and then
the
we just
C's
kind of
absorb
combine
each
it.
other?
Yeah, so like this C, so if I did each one, I would have done something like, a plus C1 here and then a plus C2 here, but I would just add those together and just call it a day with a single C.
Okay.
So no matter how many expressions you're integrating in a formula, just give 1 plus C.
Okay.
Good question. Any others? Okay, good. All right, fantastic. So now he said, we don't have a value for f prime, so I can't do shit with that. So I've just got to carry that c around. And I'm going to integrate up now to f. So integrate again to get f of x. And this is just like a number. It might be a 2 or a -5 or a pi or whatever. It's just a constant. So f of t, could you actually just take a second? Do this on your own. What's the next level? What's f of t if that's f prime of t? So test yourself. Chance to get warmed up. That looks lovely. You're all done. Yes, sir. Looking solid. Oh, wait, one more. So remember we had this C, so that C gets integrated up. So that was a 2, and then you gotta add a new constant. Am I on the right track? You are, yeah, but I would use a different letter, because we don't know, but perfect. Yeah, oh yeah, that was beautiful. That's the way. So you're gonna need 2 letters, because each time you're gonna add a new constant. We're not sure that they're the same number. So in other words, when I come here, I'm gonna integrate again 3e to the t. That's the happiest thing in the calculus world. And then I'm going to integrate 2 cosine of t. I know the cos goes to sine, and I had the plus 2, so it's 2 sine of t. Now this c is a constant, and if you were taking 2 and finding its antiderivative, you would get 2t. So when I integrate c, I get ct. I don't know what c is. So this is plus ct. And then every time I integrate, I've got to add a new constant, so you could use d there. Any letters you want. If d, you got a different letter, you're still right. It's all good. Pick your favorite letters. Could use C1, C2. That was kind of like what I was almost wanting to do, but didn't. So now, boy, now I've got these 2 conditions. I've got 2 things I don't know. But luckily, I've got 2 pieces of data. The number of unknowns you have in a problem equals the number of data points you need to find those unknowns. So we're going to put these in. So now, to find C and D, use the data. So first I'm going to plug in f of 0. I'm going to use f of 0 equals 2. And what this means is that when t equals 0, f is equal to 2. So we're going to get 2 equals 3e to the 0 plus 2 sine of 0 plus c times 0 plus d. And that all has to equal 2. Yes?
What was the reason for adding the extra constant again?
So I integrated, so down here, here's where we were right before that last integration.
Mm-hmm.
And then when I integrated, this went to the 3e to the t, this went to the 2 sine of t, this went to ct. But I integrated again, so I need to add a new constant. So every time you take an antiderivative, add a new constant.
Oh, okay.
Does that make sense?
That's just the rule to add a new constant? Okay.
Absolutely, yes. Other questions? Getting here. Cool, so this worked out really sweet, actually. What's e to the 0?
1.
Exactly. It is 1. Here's e to the x. Another great graph to know. Notice how it sits with natural log. Here's natural log of x. Those are inverses of each other. If you know that e and natural log are inverses, and you know one of the graphs, you have the other because you just reflect it over the diagonal. So if you knew this, you can do this and vice versa. So this is e to the x right here. So e to the 0 is 1. And you know what? Not only do I know e to the 0 is 1 from that, I know all sorts of other shit that we'll talk about later. But this is 2 equals 3 times 1 plus, what's sine of 0?
0.
Oh yeah, cool. Here's another great graph to know. I got a feeling I'm going to threaten a quiz on this shit sometime soon, because that sounds like me. And then I'll forget about it and never make it happen. Here's how you do one period of sine. You should know this. You should be able to sketch out a sine graph just like that. Make this little curve. Sine is sharp. It's not a triangle. It's not a sawtooth. This is pi. This is 2 pi. 3 pi over 2. This is 1. This is 2. What's between 1 and 2? 1 1/2. 3 halves. What's between 1 and 0? Half. Below points -1. Great graph to know. I would actually make a little chart, like have a piece of paper next to you when you're working with pictures and formulas that you're going to need. That chart that I gave you has this stuff on it. So you can look at this and know that sine of 0 is 0. What's sine of 3 pi over 2?
0.
1.
Oh, 1.
Negative 1.
-1. So sine of 3 pi over 2, -1. What's sine of 10 pi?
0.
Good. What is sine of 5 pi over 2?
Negative 1.
1.
Positive 1. 5 pi over 2, so check this out. 1 pi over 2 gets me the 1. 3 pi over 2 gets me the -1. So 1, 3, and then the next odd multiple would be the 5. And that would go take me up to 1. And then the next odd multiple would be the 7 pi over 2. So it's 7 pi over 2, I get back to -1. Just using that little rhythm there and thinking about it. Review, that's what this week is about. So that was a long way to say this is 0. And that's 0. Plus d, I now know d. So we got d. So we can plug that in. So now, f of t is equal to 3e to the t plus 2 sine of t plus ct plus our -1. Can you do me a favor and find c on your own, please? What's c going to be in this expression? And it won't be pretty. It will be very unpretty. Not a whole number. Okay, so Charket's with your
He
Gabe.
switched to the message.
Yeah.
Okay, Gabe. Okay, cool. You're gonna be my cameraman when I need it. So
Okay.
like at the end of class, I'll just say, Gabe, hit stop, please.
Okay, no worries.
I have a question about the sign graph. If
Yeah.
it's easier, can we use the unit circle?
Totally.
Because I have that memorized.
Yeah, that's totally great. That's great. I still would be able to reproduce that because sometimes you'll be doing geometric kind of work with it, but yeah, but if you got that, you're solid.
Okay.
Yeah, got that memorized. Good,
Yeah.
good, good. Gotten to here and doing great. Then comes algebra time, right? And that's where things can get weirder. I'll just do it, then we can talk it through. Told you. Yeah, it is. It's not a 1 or a 0. The ultimate pretty numbers. And then, boy, you gotta put it back in and type the whole expression in, and therein lies a whole other ball of wax that could unravel just typing that in. I'll show you how to type that into WebWork too, but in case you're not used to the notation of that. What I would do.
That's not the final answer yet.
No, that's just C, yeah, I gotta get back in there, Sophie, and plug that back in. So the final answer is going to be f of t, so I gotta plug that back into that top, I don't know, I felt like I had I gotta plug that back into here. So f of t equals 3 e to the t plus 2 sine of t plus, and then I gotta put that constant in, and I would actually just put the minus out in front, and then 4 plus, so that's like kind of in parentheses. I'm just getting ready to do this in WebWork speak. 3 e to the pi. Notice I just factored the negative out and put parentheses there, and that's okay. And then the d was really lovely, -1. So that would be my final answer there. Yeah, and if I was entering this for WebWork, I got this little WebWork box. What I would type is 3. I don't think you have to type the times in WebWork. Use the parentheses for the trig functions though. That's okay, that it won't think that pi is, it won't think the t's in the denominator. Yeah, I think that'll be okay, and then -1. So that's what I would enter for WebWorks satisfaction.
How do we do pi?
Say that again?
How do we do pi?
Oh, good, I think you just type pi. Yeah, thank you, that's great, Yeah, this should say pi, I think just lowercase, is that correct?
Yeah.
Yeah, cool. Good call, great question.
Do you know if WebWork will differentiate between whether or not we factor out the negative? should
Oh,
we
it'll be
issue?
happy either way, as long as it's mathematically accurate. So you could just do this, and that'd be cool too.
Okay.
Yeah, WebWorks pretty smart about math. You better be, right? Like grading your math work. Other questions? This is like the rhythm of class. This is why it's good to start early, if you can. I'll answer more questions on Friday, for sure. Are we good? Okay, we'll take that. We'll talk more on Friday. Got plenty of time. Do take a look at this. You've got like 2 of them kind of knocked out in a way. You still have to grapple with your own particular version, and that's okay. I wanted to talk about it. I wanted these conversations to happen. There's maybe 1 or 2 more conversations in there I want to have. So help me have them. All right, let's get back to integrating. Well, you guys seem pretty good at integration, actually. This seems pretty good. It seems like we got the basics down, for sure. It's just another quick warm-up, just like impromptu. What if I wanted to find the area? This is like one of my favorite calc facts. So this is going to be y equals sine of x. This is a sine graph. This is pi. This is x. I want to find the area under the first hump of sine between the sine curve and the x-axis. Could you please find that area for me? And this is harkening back to what we talked about on Monday, too. This answer is pretty. That's why it's so lovely. Oh, there's a man who knows subtle emotions in human beings. Close, actually. Let's see here.
So first off, I would do that 0 to pi. So from left to right. Otherwise, I would put a negative in front of that because you're doing kind of in reverse. Let's see, so you go close, so that's beautiful. And so cos of pi is not 0. That's therein lies your troubles.
Another great graph to know. Gotta start here. If we're not starting here, we're probably not gonna end up getting to the right place. Does that all make sense? Yeah. And that was kind of how we defined this integral, just thinking of that as the area under something. We cut that up into little rectangles, and that whole process meant this, or this means that whole process. It's a better way of saying it. Take an antiderivative, evaluate from 0 to pi, and work from left to right. So this is always your left limit, and then this is your right limit on top. Same here, the left goes in the bottom, the right goes on the top. No matter where, even if they're negatives, this is left and this is right. So we always move to the right just by convention. And so then this is negative cos of pi minus negative 0 pi. Look at how those parentheses help keep me in line. Otherwise, you might think this was 0 or something like that. Cosine of pi, there's a cosine graph, just like sine, but shifted to the left. Pi over 2, it's out of phase with the sine by 90 degrees. So then this is negative cosine, using parentheses again. Oh my God, negative, negative. Minus, minus, cosine of 0 is 1. So it is 2. How can it be 2? How can it be 2? It's so weird, it's sine. But that area is a perfect 2, it's so beautiful. I mean, you can't even draw a square nicely with an area of 2, right? It's like a square. Even a square with an area of 2 has a square root of 2 on each side. Right? That has an area of 2. Good old sine. Lovely. We're going to explore the secrets of sine and cosine this semester. Oh God, I gotta tell you. I feel like there's so many things I want to tell you in this class, like so many cool little facts we're gonna learn along the way. Well, just a minute ago, I'll answer, well, maybe I should answer questions before I get excited. I'm already excited, it's too late. Any questions on that I can help clarify, clear up? Cool. So just a little bit ago, we saw this, right? That expression showed up in there. That's a really neat thing. If you were interested in problems, you might just ask yourself which of these two were bigger, and if you could answer it without a calculator. That's just that's recreational math. Which of those two is bigger? Can you figure it out without figuring the values out? So that's just kind of fun, but that's not what I wanted to talk about. What is, just by the way, what is E approximately? What was it? What, did I hear 1.7?
2.7?
2.7, yeah, I like the one, this 0.7 just made me super happy. But yeah, E is like 2.7. This is a good fact to know as a scientist and in this class as a mathematician for making estimates. And then it's 1828, 1828, and then a bunch like forever more. But that's easy to remember, right? Impress your friends when you're out drinking this coming weekend or whatever at home, playing video games or whatever you're gonna do. That's probably what I'll do. But you can impress your friends by telling them the first 9 digits of E, and then they'll be like, what's E? Unless they're scientists, they won't care. What's pi? 3.14. Anybody know any more?
159.26583, something like that.
I think that's 4 next, but yeah, that's good. We had a competition a few years back over in Walker's Pub, I think, like who could memorize the most digits, and that's a good competition, like a pointless, silly competition. But see, now you can get a couple out there. So anyway, so this is a weird looking quantity, but a little later this semester, we'll mess around with this. What's that number? Square root of -1. That's an imaginary number. It's terribly named because they're incredibly useful numbers, like in electronics and in physics. It's the number whose square is -1. It's a weird ass number. But later on this semester, I'll prove to you this. That if I raise e to the I pi, I get -1. Now that just sounds insane. Doesn't that sound insane? And then, if you just add 1 to each side, you see this, and that equation relates the 5 most important constants in all of science together in one single equation. That's called Newton's identity. And I've known at least 3 math majors who've gotten tattoos of that on some part of their body at some point along the way. That's just ridiculous. There's another one, but I don't want to tell you. I don't think we're emotionally ready for it today. That's enough. That's enough. Sorry. Go away now. Come back later. All right. Let's push forward just a little bit. That's great. Good work. What if I had, oh gosh. Let's start down the road. We're starting down a new road. Some of you have been down. This is the substitution road that I'm thinking of right now. Without substitution, how could we can do this? How could we do this if we didn't know any more calculus than we know today? How could we do that? It was that expand it, yeah, like yeah, expand this thing out. So one route is to literally cube this thing out, right? And so, you know, this, then you foil, right? Foil, and then not something fancier than foil, but like multiply all the terms out and then you get that. Or something that I'll maybe show you a little bit later. You just kind of know how to do that. And then this is gonna be, so that's this part times x dx. Boiling that in my head. I know a trick, and you might know the trick too. It's binomial expansion, or Pascal's triangle, or some shit like that. But not today, because I've already said enough. And then I could do this and multiply that x through there. Could you actually do that really quick for me? There's no numbers, so it's like, you know, I'm not making you evaluate it. There's not as much pain involved, but let's just practice that because we haven't done a lot of it. Raise the exponent up by 1, divide by the new exponent. And then we're going to do it much more clever way. It'd be really cool. You know what I'm going to do? Oh, okay, I thought you were, yeah, we're going to do it in a really slick way. But it's good to suffer. It's good to do the math suffering so that when the suffering is removed, like you feel so good, right? Yeah. Carry those bricks from one end to the other and bring them back. Oh wait, I have a forklift. You know, could have done that. So maybe you really appreciate the forklift. So let me know if there's anything we want to talk about with that. Does that sound okay? So that's the power rule. Are we cool with that? Yeah. Okay. So just notice I just upped every exponent by 1 and multiplied by the reciprocal of the exponent. Better way. We're going to talk about substitution. And this is going to take us all definitely through next Friday. We're going to be doing this for a while. Like next Friday. Don't forget we don't have class on Monday, right? It's like cool and also like horrible at the same time. It's like so early. Couldn't we get really tired first before taking a break? Okay, so substitution. We have these basic formulas. And I'm going to call them formulas. one that I wrote over there first was this, and I'm gonna write it in terms of a new variable u. This is just called, this is the power rule. So when I say that, that's what I'm referring to, that thing there. Oh, add 1 to the exponent, divide by the new exponent. That's the way to think of it. Think of these as rhythms. This is like music, right? There's these flows that happen over and over again. And so I see this, and see these parentheses? When you see parentheses in an integral, it's signifying that this could maybe be like treated as an entity unto itself. So this thing here is, God, I wish it was just x cubed, or I wish it was just u cubed, because then I could rock this thing out so quickly it would stun everyone around me with my calculating speed. So let's look at that thing over there for just a second. So I've got this thing to the cube power, and then there's like this x dx out to the side. So parentheses, let's write this out. Parentheses create an object. It's this thing cubed, and then there's this stuff out here. This stuff out here we can think of as like the differential part. So this is a differential, this d thing here. That's just like tells you when the integral is ended and what the variable is. But I'm going to think in a slightly broader sense right now. So what if I took that thing over there, I see the parentheses, and what if I just said, oh God, I wish it looked like this. I wish it looked like this. I'm going to make it look like that. You know what? Screw it. I'm going to let u be the thing inside the parentheses. So thing in parentheses. And then I'm going to figure out what this du. So now just notice how over there there's x and dx. Here there's u and du. So I need to somehow get a du into there. So I differentiate. Bless you or something. I don't know. Yes. Yeah. Sure. Sorry, differentiate. That's what I meant to say. So when I do this side, I just say, oh, it's the derivative of u, the differential of u. This will just happen automatically. And then this side over here, what's the derivative of the right side? 2x. Yeah. So you just take your good old derivative and you tack on this. So now check out what's happening here. Like just like what is starting to materialize. This thing inside here is going to become u. And then this x dx out here looks an awful lot like this. It's just got a 2 in front of it. This has got a 2 in front of it. That doesn't. So there's two approaches here, and I'm going to I'll show you both ways. So this is kind of like step 1. Step 1. Decide what to substitute. And when I say decide what to substitute, I mean i.e. what to call u, what to make u. Because we want to make this simpler. Our goal is to make this integral look like that formula. So down here, now I've got the u, so this will become u inside here, and then there's that stuff out there. So step 2 is to solve this equation for dx. Because I'm going to take that, I'm going to figure out what dx should be in terms of u, and I'm going to plug it in up there. And I'm going to hope that things work out. So when I do that, I get dx, and I'm flipping sides here too, so let me know if this looks okay. 2x, sorry. So I basically just divided by 2x. So here, I'll write that out, divide by 2x. I think my voice is changing. A little late. Or God help me, it's changing again. We're gonna do a bunch of this. So like you might be like, where's this going? And we're gonna do it a bunch. So don't worry if it's not crystal clear at this point. Let's keep that all up there. So step 3 is going to be make the U substitution. Make the U sub that you chose. So now it's, it was up to you what to let U be. And so this is where the art of all this comes in, as you will see very shortly. Make the U sub that you chose, i.e. replace the U expression, U expression in X with U. Just the letter U. So let's do that along the way here. So that integral, the x squared plus 1 becomes U. So here, replace x squared plus 1 with just a single letter U. And then the only other substitution I'm going to do is replace dx with what I figured out it should be. I've got to copy down that x. So this comes along. So this rides along. But I'm also going to replace the dx with that thing down here. So this du over 2x. So then here, replace dx with du over 2x. And then, yeah, let me just stop for a second because I go fast. I'm just gonna make a note of what this was because I want that space. Step 4. Cancel any remaining x's. Now this could be another variable, depends on what your original variable was, or original variable. So here the x's are going to cancel, right? I got this x and I got that x, and those are just going to cancel perfectly. And so I'm going to make a little note here. I'm going to put a star. If possible. Sometimes it won't be possible. And that's an indicator that something went awry back here, or something could never have happened in the first place. So our new integral is this. Integral u cubed x here and that x cancel, and I've got like du over 2. I'm going to bring that 2 out front as a half. So here I would say bring any residual constants out front. Now look where we're at. Now we just use the formula. Yes?
Can you explain why you can take a constant and move it outside?
Yes, that is a property of the integral. So if I have an integral with a constant times a function, and I'll explain it to you geometrically too, but like just at a raw level, you can just bring that k out front on anything. But another, like a geometric way, if I think of this as like an area here, maybe I don't want to go that route. I don't want to go that route, Sophie. Okay, I'm just going to cheese out and say it's a property of the definite integral. Does that sound okay?
Sure.
Okay, cool. I was going to try to like make it intuitive, and I feel like it would just be a mess.
That's fine.
Any other questions getting up to here? Anything at all? Look at this. Look at this beautiful problem. It's the formula. It's this formula with u equals 3. So since by the power rule, integral of u cubed du is 1/4 u to the 4th plus c. Gasping for air. It's getting so incredible here. I'm going to keep that 1/2 out in front plus c. Is that cool, Becky? I saw your brows, like, if you just, I don't know, if you were like wondering about that. You good? Okay, cool. This is 1/8 u to the 4th plus c. But I didn't get a problem in u, I got a problem in x. So now I go back using the original substitution. So step 5 is back substitute. And I'm going to make a note here. If it's an indefinite integral, I don't want you to do this if it's definite. If there's numbers, I don't want you to ever go back. You will, some of you will. You're going to not heed my advice, but I'm going to implore you to not go back if there's numbers, and I'll show you what to do in that case. If indefinite, back substitute. Underlining that. So in other words, since I knew that u was x squared plus 1, our final answer is 1/8 quantity x squared plus 1 to the 4th plus c. Yes, yes, very exciting, very beautiful, very powerful. And you can kind of see, like with our work we did before, there was a plus c here, right? I didn't put it here. Can you kind of see how this could be that, right? Because you got the x squared to the 4th, you get the x to the 8th, and like all sorts of various things here. That's substitution. Let's try one together and call it a day. This, none of this, you don't need any of this on the current web work, by the way. We'll get a new web work soon, as in Friday. Start practicing this stuff. So, practice. Last thing of the day. So you summon all your energy, this is it. If you've been getting sleepy, slap yourself inside somehow, whatever you gotta do. Drink your inner coffee. I would like you to do this. Now I want to help you here. I want to help you always. When you have a root, rewrite it as a parenthesis because it's a secret parenthesis. Yes. Do not break that into 2 square roots added together. Don't do it. You're going to want to do it. Don't do it. That's not square root of 3x plus square root of 5. What are you going to let you equal? you have parentheses, you should be the thing in the parentheses. So here I would just tack on a dx then. Yeah, tack on the dx. Otherwise, great. Integrating. You want to take the derivative. So you're going the wrong direction. You're gonna make life really bad, Gabe. It's gonna be hurting. So let's see. That's because your derivative's not right. Yeah, see, no x. No. Won't that be happier?
How do you calculate the part again? And
Okay.
why is this one like those two?
So that was so the derivative of x squared plus 1 is 2x. And I just tack that on. So what's the derivative? What are we gonna, where's our, oh, here we go. Cool. So great choice. What's the derivative of 3x plus 5? Just put you on the spot because I'm right here.
This one is the 3x. Which is, are you doing the derivative? or-
Derivative.
So that would be 0, so it would be 3.
Just 3, yeah. So write du equals 3, then tack on a dx. There you go. Then solve for dx.
Okay.
Yeah. Okay. Yeah, so the du, should put that du up here. So after you do the integral, the du goes away. And I think that's what's
Oh,
confusing you
okay, yeah.
right now. But then also, this should be du over 3 here. So we put the 1/3 out front, if, or the 3 there. Yeah, yeah. Mhm. So then there's an extra 1/3 out front. Get rid of scratch that off. Does that make sense? So put a 1/3 times that. You're doing the integration part, right? Yeah. And plus C. And then back substitution. Cool. Yeah, looking lovely. Yes, very good. Oh, this is cool. What a cool. No, because, so you did this great. So, actually, you should be 3x plus 5, so let's write that.
Oh, yeah.
3x plus 5. Yeah. And then, the step in between here was the du's. Yeah, I see you're erasing stuff while you do it, right? Don't do that, because then you go back and you can see what happened. So that, this looks beautiful. Yeah, this looks, so this x would be here.
Yeah.
Does that make sense? And then, yeah, so put an angle in front of that. There you go. Okay, nice. Good. Yeah, and then a du. Tack a du. There you go. feeling about what I'm saying? Yeah, we got thumbs up. Yeah, any questions along the way? Everybody looked like they were heading down the right road, so this was good. Notice here, I knew that that was du over 3, but I don't like big bar fractions, so I like pull constant. I just made that 1/3 du, it's the same thing. And it's easy to see it comes out as a third. And then I used the power rule, and just 1/2 plus 1 is 3/2. Multiply by the reciprocal, but I already had this 1/3 up front, and the real common mistake is to lose that along the way. And so I'm actually going to simplify that before I even back substitute. And now I'm going to back substitute, and I'm going to get 2/9, and u was 3x plus 5. 3/2 plus c.
Can you explain the second part of that, like where you got the?
So to show here, we're good? Up to here?
Yeah, I'm confused, like, at that second part.
Oh, okay, so I just multiplied these fractions out. So just multiply the top of the fraction together, got 2, bottom of the fraction, got 3 times 3, 2/9. Is that the part you're asking about, Sophie?
I'm more just confused, like, what that is, like, in the context of the rest of it.
Can you give me more?
Yeah,
I'm
I-
confused too. now.
Yeah, I know, I'm really confused. Like, I know with this, you want to back substitute, but I don't know what, like, you're back substituting into, I guess.
Oh, okay. So let me kind of go through so that we can like have context together, and then we'll call it. Are you cool up to here?
Yeah.
Okay, so I made this choice. I was gonna like replace this whole expression with u,
Mm-hmm.
right? And so I did that, and then life got easier. And then I got to here, and so I just worked the problem through in terms of u. And I did this, and you were cool with that?
No, that's where I got confused.
Okay, are you cool up to here?
Yes.
Awesome. So I'm doing the antiderivative
Oh.
of u to the 1/2.
Oh, okay. That makes
Okay.
sense then.
Oh, cool.
Yeah, now we're good.
Awesome. Cool.
I was
That's
just confused,
great.
like, how you got that.
Okay, gotcha. You're getting out early. 1 minute. Woo-hoo. I'll keep track of that. I might borrow that minute in the future. See you on Friday. Don't forget we meet Friday.
See ya.
See ya.
Just at 11, right? All the time?
Yeah, just 1 hour, 11 to 12, 11 to 11:50. See ya.
No. I might.
So one Sophie's question.
So I wanted to update you on the math writing situation.
Oh, right.
So it's a little bit interesting. So I was gonna do an independent study with Dr. Bruner and econometrics, but then he decided to not offer that anymore. And so that was gonna kind of be my bridge between like econ and math to kind of see if I wanted to go down that path more. before
Yeah,
I, like,
right.
committed to- So now that he's not offering it, I'm in kind of a weird situation, right? Because both of the other math class alternatives for upper divisions conflict still with my religion class, which I'm